All right, good evening, everyone. Welcome to this week's premium live chat or public live chat too. It's Wednesday, June 15th, and we have a couple things to talk about. A little activity in the tropics. We have a thunderstorm complex that could be a threat for tomorrow morning. In fact, the mesoscale guidance is coming out. Looks like it's going to be a bit stormy, especially around the Delaware River Valley. We'll talk about why. And of course, take your questions as well. We'll see how long that goes for tonight. It's the summer, and so that typically means it's kind of hit and miss in terms of activity. No major huge storms, unless you're talking about a tropical system. But right now, not much is actually going on in the tropics, but we are going to focus on one small feature. And of course, with summer comes the potential for heat waves. Now, I want to touch on one thing before we get into all of the observations and data, and that is the model guidance in relationship to hot temperatures. More than likely, you're going to notice on your favorite app or day-to-day forecasts, especially beyond 5 days, of forecasts that go from mid to upper 90s, 100-degree temperatures, and then the next minute 70s. And the reason why is that the model guidance is going to have a difficult time handling the battle between the ridge that's going to be popping up in the Great Lakes and the Ohio River Valley and Tennessee River Valley, and just make sure everyone can see me. Make sure that that's working. Is it working? Everything okay on your end? Okay, good deal. Between that ridge and the Western Atlantic Trough, especially the Northwestern Atlantic Trough, or basically around the Aleutians. I'm sorry, not the Aleutians, the Canadian Maritimes. I'm doing good tonight. I need more coffee. And sleep. There you go, that too. And the Northwestern Atlantic, and then the Western Atlantic Ridge, that is down towards, let's say, Virginia, South Carolina, North Carolina, and the associated coastal waters out to Bermuda. We've been talking about that clash for quite some time. Now, that clash makes it very difficult for synoptic models like the European and the GFS guidance to handle the individual frontal boundaries. So as a result, once you get beyond 5 days in the forecast, you're going to see a lot of fluctuation in temperatures. You're going to see a lot of fluctuation in thunderstorm potential and high temperatures. And a perfect example would be the 12Z guidance, which for Tuesday and Wednesday had temperatures this morning in the mid to upper 90s from 0Z, and then 12Z were in the 70s. And the reason why is that is the position of the warm front or backdoor cold front, depending on how you want to read the model guidance and which guidance you're reading. And the position of those boundaries is easily a 20-degree swing. So I want to give you guys a warning now, even though but I want to just reinforce this warning that the forecast for high temperatures and extreme heat is going to be extremely volatile and untrustworthy. And it's best to wait until you get under 5 days to start to really trust that data. And even with that, let me stress that the model guidance tends to overdo the heat this time of year. So you'll see guidance that will pop out 199-degree high temperatures for northern mid-Atlantic. And by the time we get to the actual time period, we're talking about more like between 88 and 93. That is not the case for the Southern Plains. If you have friends in the Southern Plains and you're like, wow, we got like a week worth of 100-degree temperatures. Let me explain why that is more viable. The reason why that is more viable and reasonable is because you're going to have this ridge sitting over the plains and the Tennessee River Valley, that whole area, and Mississippi River Valley. And that is sustained and constant. So the reason why that forecast is more believable and the volatility is far lower is because you have an environment where you have a feedback pattern. The enhanced 500 millibar heights enhances the heat. The heat enhances the 500 millibar heights, and they feed back on each other. So as a result, you get temperatures that are basically in the hundreds very easily because your low temperatures are now feeding back into the 80s. The very warm air in the morning rises up, builds up to 500 millibar heights, which enhances sinking, which enhances the heat dome. So in locations like the plains and the Mississippi River Valley where these hot temperatures are growing and intensifying, you have the benefit of a feedback pattern. Whereas us, we do not, because we have that northwestern Atlantic trough, in the Canadian Maritimes that keeps on shoving maritime air into our region and short-circuiting any potential of a feedback pattern setting up. The last time we had a feedback pattern setting up, the last heat wave where we had temperatures in the 90s and hundreds, God, at least over 3 years. So we've been very lucky, very, very lucky in terms of not having a sustained heat wave of, forget about 3 days, talking about 7, 8, 9, 10 days. We haven't seen anything like that. So let me dive into some of the observations, and I'll walk you through for tomorrow morning why tomorrow morning looks like it's going to be a rather wet morning commute. So let me pull up this. And by the way, one other thing, the next live chat is going to be on this Monday, 8 o'clock, but on Monday. So definitely just remember that. I'll send out reminders, don't worry. Okay, so first of all, let's take a look at the tropics here. The only name in town right now is this tropical disturbance right here. Now, premium members, you'll remember I warned about this potential threat with the disturbance that was coming off the African coast about 10 days ago. It was moving into a favorable area, it had the potential. Right now, it's not looking very healthy. There's about a 10 to 20% chance that this could develop into something around the Gulf of Honduras, like right around here, and certainly around the Bay of Campeche, which is down here. Right now, there's just too much shear in place. You got this circulation right here that's kind of tearing this apart, and you have the low-level circulation right on the shore here. So I'm not seeing anything that's going to be immediate in terms of development, but it's something that we're going to have to keep on watching. In June, if you're going to look for development, it's going to be here, here, and here. So just circle this area right here. Which brings us to up here, where this morning we had some convection firing along an old stationary boundary. Notice it's pretty much collapsed because we're starting to get dry air building in here. But if I was looking for tropical development, I would look for a stationary trough or old cold front or some sort of disturbance trying to fester around here. So right now, this is the only really game in town, nothing else really to speak of. Out here in the Atlantic, see how there's not much going on? This is because of the dry Sahara dust. So the best way I would describe it is kind of like diamond dust on a baseball field when they sprinkle that down to dry out the field. Well, the Sahara on the African continent basically has dropped diamond dust throughout the Atlantic and pretty much has crushed the intertropical convergence zone. So not much is really going right now. Enjoy that while you can, because based on all data, it doesn't look like it's going to remain that way. Now, let's talk about tomorrow morning. And we're going to start off first with understanding the current environment that we're in and the observations that we are looking at. Notice our temperatures here. Very interesting. Along the coast, it is very pleasant. Temperatures in the upper 60s to lower 70s. You have an easterly wind. But then we go into Pennsylvania, and I spy a warm front. Temperatures are much warmer. Temperatures are in the 80s, with winds that are coming in from the south. And I would say the frontal boundary is somewhere right around here. Somewhere probably cutting Reading in half right around here. And this warm front is not moving all that much right now. But give it some time, because by tomorrow morning, it's going to be inching its way towards the Delaware River. And as it does so, it's going to be inducing what we call frontogenesis. Now, right now, not much really going on, okay? It is pretty much quiet, but you're starting to see an inkling of some development right here around western New York. And we have this little trough right here. So we have our inhibiting, our triggers starting to show up. So why aren't we seeing a large mass of showers and thunderstorms right now? That's a great question. Let's get you an answer. So we're going to start off with 500 millibars. You see this ridge here? This ridge axis here acts like kind of like a stopper, a substance. And that ridge axis is supported all the way down to 850 millibars. So what you have is a ridge axis over our location and a ridge axis over the Great Lakes. So again, let's step our way down. 500 millibars, 700 millibars, 850 millibars, and 925 millibars. What do we notice here? The ridge axis at each level is further and further east. So this opens up an interesting dynamic with our warm front. We don't have complete support for rising air at all levels of the atmosphere, but we do at the lower levels. We have the beginning of frontogenesis at the surface. Notice where our thunderstorms started to develop, and we can start to see that showing up here. But even more so at 925 millibars and 850 millibars. At 500 millibars, it's pretty much non-existent. 700 millibars, it's very weak. So we're making the case here that the best lifting is associated with the lower levels of the atmosphere. We also have plenty of vertical wind shear. This is cyclonic wind shear. This makes sense. With a warm front, you have winds going from the south, from the east to the southwest. Cyclonic. So you're having a turning motion in the atmosphere. And that's what we're seeing here. So we have the turning motion to support mixing in the atmosphere, to support rising air. And then we have plenty of moisture. And boy, do we have moisture. When you start getting above 1.5, in this case, we're getting to 1.7, 1.8, associated with this warm air mass that's invading, that's a lot of moisture in the atmosphere. And that supports a thunderstorm that could produce some very heavy downpours. Now, when you have a lot of moisture in the atmosphere, you have a lot more atoms bouncing against each other, which means an increased potential for lightning. You also have an increased potential for hail development because your water droplets are more likely to start to coalesce onto hailstones, which can start with a simple nuclei. Bless you. You also have a better potential for downburst wind gusts. What is that? That's when you have a lot of moisture being lifted up high up in the atmosphere, cooling and rapidly slamming to the ground. So you have a lot of these factors setting up here. I don't see this as really tornadic because even though we have wind shear, it's not the type of environment to maximize instability. Although at the mid-levels, we are seeing some indications of instability. So we know we have all this support in the observations that, hey, if we get a trigger, then we can get a nice line of thunderstorms. So let's start off first with the vorticity. Now here's at 850 millibars, and we'll jump to tomorrow morning. And you see this right here? That's your warm front. Notice at 850 millibars at this point, your ridge axis is off the coast, so you start to support more lifting, and you start to support the cold front that's approaching from the west. So you have your warm air transport out ahead of the cold front, so you're transporting a tropical air mass into the region with plenty of lifting. We see that very nicely here with the warm air transport. This is early in the morning. Look at that frontogenesis. Look at that gradient. Let's zoom in here. A nice gradient setting up. Let's go to next, right here. This is at 5 a.m. From the New Jersey shore to eastern Pennsylvania, you got about a 3-degree gradient, 5-degree gradient if we go out to east central Pennsylvania. So here again is our nice thermal gradient, which for the summer is pretty good for 850 millibars. And you can see by 8 a.m. and the rest of the day the warm air comes in. So I think that pretty much supports our warm air transport in frontogenesis. Notice during that same time period, at 500 millibars, there's next to no lifting. Not a lot of support here. So this looks like a support for plenty of moisture, as you can see with our precipitate water values supporting a very moisture-filled environment. Plenty of frontogenesis at the lower levels. So this looks like low-top thunderstorms, potential for heavier downpours, and that's support on the NAM guidance, which we can see right here again. Tomorrow morning, take us from about starting off at around 3 a.m., marching its way through to 10 a.m. Let's see, new 18Z guidance, same scenario. Again, this looks like a very heavy rainfall event, so the morning rush hour is going to be, well, not pretty. Now, how about some other mesoscale guidance? Well, the HRR, same thing. The FV3. The FV3 is what's going to be replacing the GFS, or it really has started. It's kind of a new engine, okay? And this is the mesoscale version of that. And it's producing almost the same type of scenario. And there's our cold front later, which we'll get to in a moment. Here's another mesoscale guidance. Same story. And finally, the last version of the mesoscale guidance here. So what I'm trying to show you is that basically the same scenario, the same support here. So tomorrow morning looks like a really rough morning for the morning commute, especially around the Delaware River. Expect very heavy downpours with this scenario, frequent lightning, strong wind gusts over 40 miles per hour for sure. From about, I'd say 5 a.m. to 9 a.m., it's not going to be pretty to drive in. I can tell you that right now, especially around, let's say, New Jersey Turnpike locations like that. Then after that, we have our cold front that follows through, but I'm not seeing a lot of support in terms of strong lifting here. The trough here is pretty much focused over to the St. Lawrence River Valley. So the associated cold front is likely going to feature more scattered showers and thunderstorms and rapidly weakening. So I'm not looking at a widespread severe threat out of this. And then we got another threat coming on Friday afternoon, but I'm not as impressed with this scenario, only because by the time we get to this point, we have a lot of dry air invading the region. So it's going to be a lot more limited in nature. So I think the bulk of our rainfall heading into the end of this week, over the next 48 hours, is going to be tomorrow morning in that scenario. So that's pretty much what I have for today in terms of the thunderstorms and things I wanted to cover. Not much has changed my thoughts on the long range pattern. Overall, my thoughts remain the same. Very active pattern. We'll get our bursts of heat, but they'll last maybe a day or two, if that. And primarily, we are going to be continuing to be in this clash between maritime air masses and tropical air masses, and we're caught in between. So first, we're going to take a look at the premium live chat, and then we'll jump over to YouTube and see what we got. It might be an early night. We'll see. We'll see what type of questions you guys have, and we'll cover that as we move forward. Let's see here. Even the GFS isn't spinning up any big storms in the Atlantic, Caribbean, or Gulf. Yep, right now, basically the way that the MJO forcings lined up and the very dry air coming off from the Sahara has pretty much limited our tropical development for now. Don't think that's going to last much longer. Let's see, the plains also doesn't have an influence of air coming off from the Canadian Maritimes region like northeast, eastern, and northern Atlantic. That is true. That's definitely true. Our region is really one of the most difficult regions to forecast for because you got the potential influence of basically 6 different climate zones. The northwestern Atlantic, Canadian Maritimes, the Bahamas and Bermuda area, that's tropical. The Gulf Coast, which is also tropical, but a little bit different subset. Then you got the plains, southern plains, with that type of heat. It's more of a dry heat. And then you have the Canadian prairies, which introduces your polar air mass. Not to mention Pacific air masses as well, as sometimes across the country. So really, I mean, it can be quite a bit. What's the timing of storms for tomorrow for the commute? Basically, I'm looking at between 4 a.m. and 8 a.m. for the worst conditions, and then improving after 9 a.m. Will the heavy run still be ongoing in Union after 9:15? If so, for how long after? Have doctor's appointment tomorrow morning. I think the worst would be done after 9:15. I say by 10 a.m. you're pretty much in the clear. But the worst conditions would be before 9:15. You'll be improving by 9:15. Do you anticipate any flash flooding? I think it's certainly a possibility. But I think more so off to your west, but definitely still a possibility, yes. Space Weather had an interesting piece of magnetic superstorm using the Quebec one as an example. Yeah, there is a lot of concern with the way that we have built our infrastructure and solar activity, especially with our electrical grid, and the activity of the sun of late. Let's see here. Mapping a magnetic storm. They're talking about this right here. Let's see if I can pull up this chart. You see this right here? This is bad news if we get a magnetic storm from the sun. Because aside from really messing up your satellites and your phone reception and everything else that we use, it would seriously screw up the electrical grid because it creates an inhibiting factor. And we are at the worst potential for that in anywhere where we're in this zone here. So you're talking about the northern plains, talking about parts of the Great Lakes, but especially the East Coast megalopolis. You get a really strong magnetic storm and it hits the earth just right, you're going to be dealing with some power outages for the eastern United States. And this is what essentially this map shows here. The greater the resistivity, the higher the potential. And as you can see, well, we are in ground zero of that potential. All right, now if you head off towards the Rockies, it's less of a threat. But as you can see here, the East Coast is not set up to deal with that type of scenario very well. So it is certainly a concern and something that we're going to be studying. I know there's a lot of study about that. The Great Quebec blackout was caused by this scenario. And of course, after a bit of a quiet period with our sun's activity has ramped right back up, and we have a CME expected an impact, well, today. So that might be another factor that could cause problems with your cell phones and satellites and whatnot. So this is a great example of why this is an issue. Okay, you have your power plant here, right, and sending its electricity across. Now, the way that the magnetic field deals with our Earth's crust, you have your power lines, and what this is your induction of resistance of the electrical flow. So if you start to get greater influence because the space weather derives electric current fields and magnetic fields in the Earth's atmosphere, if you increase that resistance, guess what? the electricity that is coming out of the power plant doesn't get to your house. There's your blackout. And you get this feedback, and it can create all sorts of mess. So anyone that tells you the sun doesn't matter on the Earth's atmosphere and everything that works with the atmosphere, you're going to get a really harsh lesson if we get one of these CMEs to actually impact us right. Has there been any change to your tropical thoughts considering the basin and stratospheric chats along with the SAL? No, none. I've seen this before. The SAL collapses and then boom, you just get activity coming out of the woodwork here. Never make a change in your forecast based on what happens in June. June is usually a very quiet month. It's kind of like, if you want to compare it to winter season, it's kind of like if you get a rogue snowstorm in November, or you don't get any snowstorms in November, early December. People think that, oh, well, it might not be active because it didn't snow all that much by December 10th. And then all of a sudden, all heck breaks loose, right? It's kind of the same scenario in June with tropical Atlantic. June is a very quiet month on average compared to the rest of the tropical season. If it was like this in September, then yeah, my forecast and pretty much everyone else's forecast would be in a lot of trouble. But right now, there's way too many favorable scenarios setting up here to have me change my thoughts on it. Good. The AC forecast was a big help. Good. I think that's awesome. Steve, tomorrow afternoon, Williamstown High School graduation at football field number 2. The weather will be okay. No worries of downpours, correct? Let's take a look. 2 p.m. Let's see. Let's take a walk through here. It shouldn't be too bad. I would have a small umbrella handy just in case of a passing shower. But overall, it shouldn't be too bad at all. You're going to be in between the warm front influence from the earlier in the morning and the cold front influence for later in the evening. Like we're talking about like 9, 10 p.m. So you should be fine, but just have a small umbrella as a backup plan just in case. I think hardening the grid from EMPs and geomagnetic activity is something that is really needed and is being massively overlooked by those who can actually carry it out. Yeah, there's a lot of things that we need to invest in terms of infrastructure and protecting our infrastructure. And man, we could have a 2-hour chat just on that alone. Bridges, our electrical infrastructure. I mean, they're talking about doing all electrical vehicles, but can our infrastructure handle that type of electrical output in the first place? Can we generate enough electricity in the first place to support that type of pull on the electrical grid? I don't know. The way that our electrical grid is now, maybe not. I mean, think about this. Let's say we get a heat wave. You're charging your electric car, and you have your air conditioners going, and you have your computers going, and your TV, and your Wi-Fi, your refrigerator. That's a lot of electricity being pulled onto this grid. It's a reasonable question to ask whether or not we can even handle that alone without any type of impact from CMEs or anything of that nature. Okay, so EPM issues also. I mean, geez, that's a lot of stuff. And hopefully someone much smarter than me is actually trying to tackle it. It seems we are getting waves of sunspots, almost as if one side of the sun was more active than the other. Is this just a perception, or is there any data that addresses that one way or another? Given we already had the sunspot with the atypical polarization, it makes me wonder what else may be going on. Looking forward to seeing continued observations and new equipment we have. Based on the data we have, I know we have satellites monitoring all sides of the sun. It's pretty much posted public what's going on Earth facing, because that's usually the side that is the most concerning. Looks like the Mets just hit a home run. There we go. Get back on board. Of course, I got the Mets game on back here, so of course. Where was I? Oh yeah, the solar activity. We know that they have data, and there's nothing that stands out that's unusual. So again, I'll see if I can pull in some data, see if there's anybody willing to share that publicly. But there's nothing that's really too unusual. Even the quiet period of the sun that we saw, pretty much par for course, even for an active solar period. So not anything that's all that surprising. Let's take a look at the YouTube chats. Hello, Judy. Mark, how you doing? What are the predictions for the 2022 season? In terms of, I'm guessing, the tropical season, I've already posted that back in May. Basically, I'm looking for a very active season. One where easily over 14 named storms, potentially for about 5 major hurricanes this year. That does not mean, I want to make this very clear, that does not mean that 5 major hurricanes will hit the United States. I can't make that prediction. No one can. Okay? So we could easily have 5 major hurricanes that all stay out in the Atlantic. Entirely possible. Or 2 hit, or 4 hit. Oh, the Mets, no, that's just not fly ball. Or you could have all of them miss, all of them hit. I have no idea. But I do think we have the potential for 5 major hurricanes this year. Let's see here. Already named the thunderstorm thing. Will it be hot for July, August, like 90 plus for a week? Okay, well, I can't rule it out. I think that the threat is low. But if I'm going to find that those type of conditions in the heart of summer, it's kind of like saying, well, we have a week in the lower 30s in the winter. It's the winter. Of course, there's a chance. In the summer, yeah, you could definitely have that chance of 90 plus temperatures for a week. If I'm going to find a place where that's going to happen, I would say I'd focus on southwestern New Jersey and southeastern Pennsylvania, i.e. the Philadelphia metro. Because you're in that zone, if I may for a second here, right in this area right here. What happens, let's see if I can zoom in. You see this right here? This area is able to get very hot air funneled in from Virginia, get enhanced by the heat islands in Baltimore and Washington, and gets transported right into the Philadelphia metro. Now you get this transport combined with a westerly wind coming off the Appalachian Mountains, and what you end up with is a perfect scenario of temperatures being able to spike to the maximum potential of your 850 millibar temperatures. So if you have 850 millibar temperatures around 19 degrees Celsius and those conditions all align, then this area is most likely to see your temperatures spike up into the lower to mid 90s very easily, even upper 90s, okay? Now, what makes this year interesting is that you're going to constantly get this influence from maritime air masses coming in from this direction. So the reason why we're going to have a more difficult challenge of supporting heat waves is because you're going to have a greater potential via easterly winds to cut down that potential of high temperatures in the 90s consecutively. So you might have one day in the mid 90s, then you fall back into the lower 80s, and then spike back up into the lower 90s with the retreat of the front. Then the cold front comes in from the west, and so then the next day we're back up into the upper 70s to lower 80s. So it's this summer is a very volatile summer in terms of temperature regimes and supporting a locked-in temperature pattern, like with temperatures constantly above 90 degrees because of that scenario. Let's see. California has shown so far that it can't. They have told people not to charge cars in the evening when everyone runs ACs. Of course, they have plenty of brownouts and rolling blackouts. Well, California is kind of like its own little petri dish of trying to figure out what their energy policy is. So I'll just leave that as it is, and we'll go from there. If that big polar high at 10 millibars normal for this time of year? Yes. I don't even need to look at the data. Yes, it is. In the summer, your heights rise well above what you would normally see in the winter, which is typical. And the reason why is because all your ozone's being destroyed. So you're having massive cooling. And because of the destruction of the ozone, you're seeing this enhancement of heights at 10 millibars, 5 millibars, and then down to 50 millibars. So that's why you're seeing that evolution. It's kind of like the opposite of a major polar vortex. So yes, it's very, very normal. Also, the 500 millibar and 250 millibar amplification still looks impressive. That's typical of La Nina. If that is that usual for La Nina summers, and is that dependent on La Nina strength? Yes to both. Okay, so La Ninas typically enhance the polar jet stream and weaken the subtropical jet stream. So your polar jet stream tends to be far more amplified, and you get this evolution of a stronger polar jet stream as a result. This is also why you get a stronger upper level low or trough around the Aleutians, which translates also to a trough around the northwestern Atlantic and eastern Canada. So in short, yes, it's very much normal to see this. Okay, and it looks like we have knocked off all the questions for this evening. There's some pretty good questions too. Okay, so we'll go on for another 4 minutes, and if I don't get any more questions, we'll shut down for the night. We'll take a look to see if we have any observations that might stand out. Well, we already have a nice little severe thunderstorm cell over western New York associated with our warm front. Now, I bet you that matches up with, there's our instability, and there's our wind shear, and there's our thunderstorm. It all lines up very nicely. So the scenario definitely is setting up for us to have a rather stormy morning here. Let's pull up the latest HRR guidance and see if we have any update on that. And again, you'll probably start hearing some rumbles of thunder after 2 a.m. over eastern Pennsylvania. By about 4 a.m., it starts to move into the Delaware River Valley. See thunderstorms throughout much of eastern Pennsylvania, Reading, Mount Pocono, Allentown, Williamsport. And by 6 a.m., it's throughout much of eastern Pennsylvania and western New Jersey. By 8 a.m., it's throughout much of New Jersey, pushing into New York City Metro. Notice it's a little bit weaker by this point. And by 10 a.m., it's pretty much done. Any early thoughts for July 4th weekend? Not really yet. Let's follow back up on that on Monday. I should have better data on that. The guidance I have right now is really, really preliminary. And in terms of precipitation, nothing really stands out. In terms of the 500 millibar pattern, pretty much what we're dealing with right now. Nothing really too significant changing. But in terms of where frontal boundaries are located, whether we deal with any rainfall, I don't have any reliable data just yet. Topic for next Monday. Well, first of all, July 4th weekend. There's one topic. Probably to see what I usually do. The way I usually set this up is I look at any type of scenario setting up for the next 48 hours. Okay, so that's one of the things I usually focus on because everyone's going to ask about it anyway. Of course, tropical activity, anything popping up there, major holidays, 4th of July weekend. I'll probably get a better read on La Nina. So fresh La Nina data will probably cover that and see if there's anything unusual with that. And I think that pretty much will cover it for next Monday. Of course, something's going to pop up too. And of course, I always keep an eye out to see if there's any interesting new climate data. There really isn't anything really standing out that's really brand new in terms of climate. In terms of any type of new information or anything like that. There has been some interesting pushback on the heat wave data in terms of deaths and impacts. This is always very interesting because if you go by heat index, there's definitely been an increase. But at the same time, our ability in the United States to handle heat impacts has improved immeasurably. Because, technology, right? Air conditioner, cooling zones, stuff like that. On the other hand, if you go to places like India or the African continent or portions of Southeast Asia where you don't exactly have the most optimal technology in place, well, it's becoming a bit of an issue because it's literally killing people. Thing is that's nothing new, especially for the subcontinent in India. It can get very, very hot there with or without us. So that's always subjective. So it's interesting. There's a lot of debate and argument on that. In some respect, you can't. In terms of the humidity, there's been an increase. In terms of loss of life, depending on where you're looking, there's been a decrease and there's been an increase. And that comes all back down to technology. Montreal has very humid summers. Yeah, they would. Think about this, okay? Montreal, let's see here. Hello from Montreal, Canada. Yeah, there you go. Okay, so that makes sense. If you're having southwesterly winds, you have an influence from the Great Lakes. Absolutely. Now, what I'm interested in is whether or not there's any difference in terms of winds and the nature of humidity. Like, for example, if you got more of a wind coming off of, let's say, the Lake Erie and Lake Ontario coming in, that's obviously humid. And then you got an air mass coming in from the Ohio River Valley, so that's going to be a humid summer. And then you get the urban heat island effect. But then if you get winds coming in from the north, it can't be that dry because you also have the Hudson Bay nearby. I mean, it's huge. So it's interesting to see, you may have cooler conditions with a northerly wind or northwesterly wind, but you retain the humidity. The only dry weather pattern probably a due west wind in Montreal. Yeah, due west. Well, west northwest, because then you bypass the Hudson Bay and you don't get any influences from the Great Lakes. Let's see here. New York City Metro looks like clear, stable marine air mass for the wind. Well, yeah, we'll see. Anything going on in the West Pacific right now? Nothing right now of note. Nothing significant. There's a tropical depression, but not really all that impressive. Are deaths caused by human stupidity? Always. And malfeasance, such as leaving children in hot cars in the sun. Malfeasance. Yeah. Well, you know me. My job is to butcher not just one language, but two. I'm butchering the Spanish language as well as I'm butchering the English language. I let everyone very happily know, as I am learning Spanish, I am able to destroy that language just as easily as I could destroy the English. Well, that's true. Yeah. Look, in terms of deaths, I don't know. I don't have the data to really dive into that type of analysis, but I never underestimate the stupidity of humans, unfortunately. St. Louis River is very wide by Montreal. Lots of moisture comes off at times. I believe it. Let's see here. Oh, I got a question from Kobe Bryant. Hello, how you doing out there? Thoughts on naming heat waves like hurricanes? No. Then that's a big no for me. I know it's a bit of a gimmick like TWC naming winter storms, but it could work with heat waves, I feel. All right, so how do you pull it off? Well, all right, here's the positives and here's the negatives. Positives, much like tropical systems, you pretty much have one standard. It's a standard temperature, 90 degrees plus, and humidity. If you have that type of standardization, could you name it? Sure. But there's a problem with that. And that is that, well, in one region, let's say our region, okay, a heat wave is kind of rare, right? I mean, relatively speaking. So it stands out, right? But what do you do if you're in Texas or Oklahoma? It's perpetually over 90 degrees. Do you name that? How do you not name it? Is there a different standard to naming it? So it would definitely work in more of your temperate climates as you head towards the Great Lakes, the Northeast, Northern Mid-Atlantic. I'd probably take out Washington, D.C., but yeah, definitely. But how do you handle that in Florida? How do you handle that in the Gulf Coast? And more importantly, how do you handle that in the Southern Plains, where you're going to have stretches where you have temperatures like now, perpetually in the 90s. Your average temperatures are in the lower 90s. So for them, it's a heat wave, but it's kind of like for them, it's Tuesday. You know what I mean? It's not that it's not something that really stands out to them. So then you'd have to make an adjustment in terms of the region, which then brings back the same problem with naming winter storms. My big problem with naming winter storms was that a snowfall of 2 inches in New York City is a yawn. 2 inches in Oklahoma City is Armageddon. The whole city has shut down. Oh my God, we have to wait for the sun comes out. And literally, I was told this when I lived in Oklahoma. God brought it, and God will take it away. When I asked when are they going to remove the snow from the street. And in some cases they were right, because the next day they were in the 50s and everything was melting away. So what am I to say? But you see how 2 inches for us is no big deal. 2 inches for them is literally shutting down the whole city. So how do you name one and not the other? Same thing with heat waves. 95 plus for us is a major news story, major impact on life. You have cold centers setting up. You have concerns about the heat index, and you have concerns about loss of life. But if you take that same scenario and put it in Texas, and you say, oh, it's going to be 95 today, and they're going to say, oh, it's cool. It's a cooler day. Good. How's the humidity? Oh, it's a little lower. It's only 80 degrees for a while rather than 85. Not too bad. Maybe I'll jump in the pool. You see my point? They don't consider it as big of a deal. So then how do you name that? So the reason why you can name tropical systems is that regardless of where you are in the world, a tropical system is going to have the same impacts whether you are in Maine or in Florida, whether it impacts Cuba or it impacts the Canadian Maritimes. It's the same structure, same impacts, same concerns. So then you can name it because it has all the same attributes no matter where it impacts. The Yankees are on pace for a historic season. Yes, until they run into the Mets. In Arizona, 95 is chilly summer. It's chilly summer day. Exactly. That's my point. That is my point exactly. Um, when it comes to temperatures and when it comes to um, things like that are regionally dependent, it's very tricky to name something like that. And let's be honest. I mean, the media in general has a very, and I guess I do too, have a very East Coast based bias in terms of what's important weather. Like, let's be honest. I'm not going to talk about major fire weather. That's not my audience. But then again, I mean, hello, NYNJPA weather doesn't exactly include Colorado, right? But in terms of the national news, you don't always generate that type of coverage. Recently you have, but it isn't always the case. So, no. Look, hey, Cubby is an excellent. There's no reason to block anybody. I don't know who the heck that person is, but actually, Cubby asked a very good question. I got no issues. Very good, excellent question. During the second half of the summer, well, define bad. Oh, good. My wife kicked some butt. Good job. Yeah, honey, can you make sure that Cubby is okay? Okay, no worries. Um, let's see here. But yeah, I mean, some people. Let's see here. I feel like thunderstorms are going to be bad during the second half of the summer. It's possible. Can't rule it out. Absolutely not. And we're going to look at some data real fast, see if there's anything new observationally. Let's pull up the new NAM. If we have the 18Z runs just coming in. So let's see if we have anything new there. I hope if I pull up the image first. Yeah, I would say that the worst conditions are likely to be focused around eastern Pennsylvania around 4 a.m. to 6 a.m. So definitely be on guard for that for tomorrow morning. I'm just going to put that out there. All right, so it is 8:52. I think we had definitely a great chat. If you have any more questions, not, we're going to shut it down for the night. And I will be back on Monday with another live chat. And we'll discuss all of the factors that we're going to be dealing with. So again, I'll see you on Monday. Thank you for coming in to visit. And as always, stay safe out there.